So this is maximize z, maximize some objective function. Then there are only two constraints in this example, and this last one is the non-negative constraint. Okay, so let's start solving this. So remove the inequality signs from both the constraints and just keep the equality sign. So 12x1 plus 20x2 equals to 40. This is my equation number 1. Yes, what I will do, I will divide this complete equation by with 40, so that I have just 1 on the right hand side. So that gives me what? 12 upon 40 is what? 4 3s are and 4 10s are. Okay, 20 upon 40 is 1 by 2, and this x2 is there, and then this is 1. Correct? So this gives me the 2 points. Correct? So this is what? x1 means what? Whatever is below x1, that is your coordinate on x-axis, right? But then there is 3. What to do with this 3? I don't want it there. So how can I write it? So x1 divided by 10. Take this 3 on the division of this 10, right? I can write it this way. This is also correct. So x1 divided by 10 by 3 plus this x2 divided by 2 equals to 1. Sure? Okay. So this gives me the two coordinates A and B. What is coordinate A? That is nothing but this x1, this is 10 by 3 on the x-axis, and then 0 on y-axis, and this is what? This is x2. Correct? So this is 2 is on y-axis and 0 on x-axis. Now take the second equation, that is what? x1 minus 4x2 equals to 4. This is your equation number 2. Now divide this complete equation with 4, so that I have 1 on the right hand side. So that gives me x1 by 4 minus x2 by 4 upon 4 is 1 equals to 1. Yes, but in this case you have to observe this is minus sign. You always, for this trick, you always have to have plus sign. So how can I write it? Just put this plus sign here, and this is your complete minus here. Yes, so this gives me the two coordinates, which are C and D. So what are those two coordinates? C is what? 4 and 0, and D is what? Minus 1. Correct? This minus sign is there. So D is minus 1 on the y-axis and 0 on the x-axis. Done. Let's plot these points quickly on the graph paper. For that you have to take a look at the coordinates. So for coordinates I can see maximum 4, right? 10 by 3 is also like 3.3. Okay, so I will do it with the, I'll write it with the gap of 1, 1. Correct? I can even do it with 0.5 distance for the accuracy purpose, but then 1 is also fine. So I'll write it down 1, 2, 3, 4, 5 and so on. 1, 2, 3, 4, 5 and so on. Correct? This is my y-axis, this is my y dash, this is x, this is x dash, this is origin, which is 0, 0. Right? I would need, this is minus, correct? So I would need minus 1 point also here on the y-axis, correct? So yeah, 10 upon 3 means 3.3 on the x-axis. So this is say 3.5. So I will plot this point A here, which is nothing but 10 by 3, 0. 10 by 3, 0. What is point B? 0, 2. Straight away, this is point B, 0 and 2. Let's join these two points to form equation 1. This line, correct? Now, plot these points 4 and 0. 4 on the x-axis. This is point C, 4 and 0. And what is D? 0 minus 1. 0 and on y-axis it is minus 1. So this is point D, 0 minus 1. Connect these 2 points to form a line number 2. So let's connect these 2 points. This is my line number 2. Yes, when you are doing it on the graph paper by using scale, it is going to be very, very accurate. Okay, I am just showing this. I want your concepts to be cleared. So don't focus on this, part a lot, like this line. Those are not very straight, I know, but still focus on the concept which I am teaching you. Okay, now let's look at these inequality signs to find out the feasible region. So both are what? Less than or equal to, less than or equal to, correct? So feasible region is towards origin. So for this line it is quite easy, correct? The feasible region is this way towards origin. This is origin, right? So this is going this way, correct? Now for this second line, as this is passing through the negative side of y-axis, towards origin means it is going this way, correct? Upper side. It is going this way, this way. Yes? So now what is the common region which you see here? That is nothing but your feasible region. So I see the common region as this. Correct? I see this as the common region. This is nothing but your feasible region. So you already know all the coordinates, correct? What are those? Those are nothing but OBA or OAB, you can say. OAB is the feasible region, right? And the next part is what? You have to find out the coordinates of these points. But you already know the coordinates well in advance, correct? O is nothing but 0, 0. A is what? Here it is, right? A is what? 10 by 3, 0. And B is what? 0, 2. So you already know. So this part is saved. Okay, this part of calculation is saved. So next part is what? Directly put these values one by one in your objective function. Okay, so let's do that part. So basically you have to find out what? ZO, ZA and ZB. Okay, so what is this ZO? What is the objective function? 3x1 plus 5x2. So 3, this x1 plus 5, this x2. Everywhere it is going to be this way, correct? For all the 3. Okay, and then you just have to put the coordinates. So for O it is what? 0, 0, origin. Yes, so this is going to be 0, correct? For A, it is, what are the coordinates of point A? 10 by 3 and 0. So put this 10 by 3 here and 0 here. So this part becomes 0, this goes, so this becomes 10. And what are the coordinates of B? 0, 2. So put this 0 here, 2 here, so this becomes 0 and this is 10. Now check what is this. Is it maximize or minimize? What is the objective function? To maximize the solution, right? So whatever is the maximum number you get here, that is your final solution. That is your optimum solution. But now you got the two maximum numbers, right? 10, 10. In both the cases means this problem has multiple optimum solutions. Both the solutions are correct. And how are you going to conclude this problem? Saying that ZA is equal to 10 and ZB equals to 10 are the optimum solutions for given LPP with the coordinates as 10 by 3, 0 and 0, 2 respectively. Okay, this is the multiple solution LPP. So that's how you have to write down in the conclusion part of this problem.